Welcome to Get Your FRQ On. This question is from the 2015 AB exam. It's number 6 and it is not a calculator question. For the stem of this question, we're given an implicitly defined function with x and y, and we are given a formula for dy dx. We do not have to verify it, we are just given it. But for part A of this question, we are asked to write the equation of the tangent line at the point -1, 1. Well, in order to do that, we have to know the slope of that tangent line, so we will evaluate dy dx at the point -1, 1. So if we evaluate dy dx at the point -1, 1, substituting 1 in for y and -1 in for x, we eventually get 1/4. Now that I know the slope of that tangent line, I also know it has to go through the point -1, 1, which means I can write the equation of this tangent line in point-slope form. My y-coordinate is 1, my slope is 1/4, my x-coordinate is -1, so that equation would be y minus 1 equals 1/4 x plus 1. In part 2 of the question, we are asked to find the coordinates where the tangent line is vertical. Well, the tangent line will be vertical when the denominator of dy dx is 0. In other words, the expression for dy dx would be undefined. So now I need to set 3y squared minus x equals 0. And if I do that, I can get 3y squared equals x. So I'm going to substitute 3y squared equals x into the original equation. Y cubed minus 3y squared y equals 2 implies that y cubed minus 3y cubed equals 2. That simplifies. We have a couple of y cubed terms. And eventually we can determine that the corresponding y-coordinate would be y equals -1. Well, if y equals -1 and x is 3y squared, x would have to be 3. So we are interested now in the point 3, -1. That should be where the tangent line is vertical. For part C, we are asked to find the second derivative of y with respect to x at the point -1, 1. In order to find the second derivative, we have to find it and then evaluate it. Well, to find the second derivative of y with respect to x, or d2y dx squared, we have to differentiate dy dx, which was given to us in the stem of the problem. So dy dx is y over 3y squared minus x, and we have to differentiate that. Notice that this will use an application of the quotient rule. So if we apply the quotient rule, we're going to get 3y squared minus x times dy dx minus y times the derivative of 3y squared minus x, which is 6y dy dx minus 1. And then all of that over 3y squared minus x, quantity squared. Now, you might think we have to take the rule for dy dx and substitute it back in to the rule for d2y dx squared, but we don't have to do that because we already know the value of dy dx at -1, 1. We determined that in a previous portion of this question. That is 1/4. So we can just substitute 1/4 wherever we see dy dx. If we do that and evaluate the rest of it at the point -1, 1, we eventually get that d2y dx squared is equal to 1 over 32.